Good morning. Today our topic is the fluctuation. Basically, fluctuation is a deviation of mechanical variable. Mechanical variable, for examples, pressure, volume, energy, number of particles from its mean value is called the fluctuations. Let us consider a quantity energy E, then the fluctuation in energy is defined as delta E upon E. This is called the fluctuation in energy. Similarly, then the number of particle in fluctuation is called the concentration fluctuation. Our main topic is fluctuation in the ensemble. If consider a canonical ensemble, basically this is an ensemble in which temperature T, number of particle and volume are constant. Therefore, the exchangeable parameter is energy. So, if fluctuation in energy is very small, then canonical ensemble equivalent to the micro canonical ensemble. Similarly, if the fluctuation in number of particles and E is very small and basically they are exchangeable in a grand canonical ensemble, therefore the fluctuation, that is the delta n upon n and delta E upon E, is negligible, here tending towards 0, then all ensemble are equivalent. Now we are discuss about different concentrations. What is the mean square deviation? Consider number of particle or consider a quantity N and its mean value, or we can say that average value, is represented by the n bar. Then the deviation is noted by, as we know that delta n is equal to the n minus n bar. This is the equation number 1. Now or we can say that the average value of delta n, that is the bar, is equal to the, simply we can denote it as the delta n. This is equal to the n minus n bar and its bar, that is n bar minus n bar and again bar, or n bar minus, this is equal to the, not n, this is the n bar, so this is equal to the 0, or we can say that this is the equation number 2. Now considering equation 1, on squaring on both sides, delta n of square is equal to the n minus n bar whole square. This is equal to the n square minus n bar square minus 2n n bar, or its average value or mean value, that is the delta n square of its mean value, is equal to the n square minus n bar square minus 2n n bar and its whole bar, that is n square bar minus n bar square minus 2 n bar and n bar and bar, that is n square bar minus n bar square minus 2n bar and its square, that is this is equal to the n square bar minus, this becomes the n minus, sorry, a square plus, and here is again plus, and this is the plus plus, so this is equal to the n square bar minus plus and minus minus n bar and its square. Equation number 3. That is, we can simply note it out. Delta n square and its mean value, or this is denoted as delta n square, or like this symbol, this is equal to the n square bar minus n bar square, or this is equal to the n minus n bar of square and its whole bar. So basically this is the mean square deviation of a quantity small n, yeah, simply this is called the concentration in the, yeah, or fluctuation in the concentration. Now our main topic is the fluctuations in ensemble. Here our main first topic is the canonical ensemble. Canonical ensemble basically is an ensemble where, as we discussed about, temperature T, number of particles N and volume V are constant, or we can say that a system is in thermal equilibrium with the reservoir is the contact as the canonical ensemble. Therefore, exchange in temperature is not possible. So fluctuation only in the energy. So our topic to concentrate about the fluctuation in the energy in case of the canonical ensemble. As we know that the energy is given by how? Energy basically defined as the E is equal to the summation I of Ni and Ei, and the average energy, that is denoted by the E bar, or like this symbol, is equal to the E upon N. This is equal to this implies that summation Ni Ei upon N. Here is the I. As we know that the probability distribution Pi is equal to the summation of Ni upon N, or we can, using this value, the average value or mean value of energy is equal to the summation I. Basically this is equal to the Pi. So Pi and Ei. Equation number 1. As the Pi is the probability distribution, which is probability distribution Pi is equal to the summation of Ni upon my capital N, Ni upon N, and Ni is equal to the e to the power minus का अल्फा प्लस बीटा epsilon I, or simply we can say that this is the Ei upon summation I e to the power minus alpha plus beta Ei. E to the power minus alpha will be cancelled out. So Pi is equal to the e to the power minus beta Ei upon summation I e to the power minus beta Ei. Using this value in equation number 1, we E expectation, or this is equal to the E bar. This implies that using this value e to the power minus beta Ei upon this, summation I ei e to the power minus beta ei upon summation I e to the power minus का beta ei. Equation number 2. Also, we note that the partition function z is equal to the summation I e to the power minus beta ei. Using this value in this equation, e bar is equal to the summation I ei e to the power minus beta ei upon z. Now, our main concern about this topic. E bar is equal to the, this term can be represented as here 1 upon z e to the power minus beta ei, and if we differentiate with respect to the curly upon curly beta and we get this value, बिकॉज बीटा के रिस्पेक्ट में जब डिफ्रेंशिएशन करेंगे तो ई आई कॉन्स्टेंट के साथ में आपको यहाँ दिखाई दे रहा होगा विद ए नेगेटिव साइन. दिस कैन टर्म रिप्रेजेंट लाइक दिस. सो here we use अपना simple, this is the epsilon I and z is equal to the summation I e to the power minus beta ei, that is minus 1 upon z, and this term be denoted as curly z upon curly beta, and this is the value of the e bar and known as the equation number 3. Now, similarly, or this simple can be represented as the expectation value of this one. Now, here we find out the expectation value of the energy, or simply this is the E bar. If talking about the expectation value of the E square, what will we get? This is equal to the E square upon n. Now using summation term, this implies that summation I n I E I square, not n square, upon capital N. This term again known as the probability distribution, that is summation I pi and ei square. What is the value of the p? This is equal to the pi is the probability distribution, that is e to the power minus beta ei into e square upon summation I e to the power minus beta ei. Again, this term is equal to the partition function z, that is 1 upon z summation I ei square e to the power minus beta ei. This is the expectation value of the e square. Again, we repeat this partition function or expectation value of e square in terms of the beta. So how can we use it? This is equal to the, as we discussed in the equation number 3, that is e square is equal to the 1 upon z. Actually, we have to find out the value of this one with respect to the differentiation beta, that is e to the power minus beta ei. If we differentiate first time curly upon curly beta, what will we get? Minus epsilon I. But now we use e square I. Therefore, again differentiate with respect to the beta, we get plus e square and this term. So we can use this value is replaced by the this term, that is 1 upon z again this value is equal to the partition function z. So 1 upon z curly 2 upon curly beta square of z. Now don't use this value because already we have represent this value in terms of the e square. Therefore, this term not be represented here. That is e square of expectation value is equal to the this term. Now equation number 4, we have already represent of energy E. Yeah, expectation value of E is equal to the 1 upon Z one upon Z curly Z upon curly beta with negative sign. Already this term used previously as equation number 3 or 2. Now on differentiation, equation 3 with respect to beta, what will we get? Curly upon curly beta of E is equal to the minus, first this term will be constant, curly to z 1 upon z, therefore this is equal to the curly to z upon curly beta 2. Now differentiate this term, so minus 1 upon z differentiation, this is the minus 1 upon z square and curly z upon curly beta into this value, that is the curly z upon curly beta, that is minus 1 upon z curly to z upon curly beta 2 plus 1 upon z square curly z upon curly beta square. By negative sign, minus curly expectation value of E upon curly beta is equal to the plus 1 upon z curly to z upon curly beta 2, and this term will become negative 1 upon z square curly z upon